Good afternoon, SEMA. Welcome to the Collision Refinish stage. I'm Scott Caboose with iCar, and with me today, Dean Brennan with IPG Photonics, and Jeff Poole, also with iCar. And I'll let you guys just say a few words about yourselves, and Dean, especially you, your company, and what your involvement is here with laser welding.
Well, thank you. IPG Photonics is a leader in fiber laser technology, and we have developed a product. We've been selling lasers for welding in automobiles for years and years, and now we have a product that's a handheld delivery system for the laser. So it's really bringing laser welding to the masses.
I'm Jeff Poole with iCar. I'm the subject matter expert team leader, and I have the pleasure of working with one of these units up at our Appleton facility. I am by all means a newbie. I have a lot to learn, and so hopefully today here with Dean will enlighten some of my knowledge and yours on this process.
So I guess I could introduce some of the dry stuff, how a fiber laser actually works. So we can get into it. Is this up?
Yeah.
Okay, great.
There you go.
So I'm going to discuss a little bit about what fiber laser technology is. I'm going to talk about some of the advantages of fiber laser cutting or welding, and the applications related to automotive. So the fiber laser is actually a semiconductor product. We actually manufacture a semiconductor fab shop in Massachusetts, and we create these 3-watt emitter diodes, and these diodes are combined to create light that is amplified inside of a fiber optic cable. And that actually creates the laser that you're using for the welding. So we're able to deliver the beam through a fiber optic cable without any mirrors or any type of alignment or anything. It's all built into the system.
So contrasting that with welding that we're used to, where we're using amperage and heat, we don't have the heat problem here, right? We're not introducing that warpage into the panel.
Right. If you think about when you were a kid, you had a magnifying glass and you lit a leaf on fire using the power of the sun. That is more like fiber welding than it is welding with electrons. So we are actually using photons of light that have a wavelength that couple with the metals that we're working with. Doesn't work great with plastic. You're not going to be able to weld dirt, but you can weld metal.
And just about any kind of metal.
Yes, yeah, it's agnostic to that.
Excellent, thank you.
So this is just a slide showing what the inside guts might look like in a fiber laser resonator. And that's the unit there. It has it's very easy to use in that there's presets in the machine. So if I'm welding a part that's maybe 20 thousandths thick and I'm welding it to another 20 thousandths part, I can just call up a preset. Oh, this is aluminum. Hit that button, and the actual laser conditions are going to come up automatically. So the adjustments that are made by the operator are very minor.
Yeah, and we got a chance to go out to your facility and play with it a little bit before we bought the one for the training center. And we found it was very simple to use. The learning curve, it's not the same as welding. It is very different. Matter of fact, those of us that have welded before, done mag welding, struggled more than the people we brought that had never welded before. They actually caught on very quick, and they didn't have the bad habits already.
That's right, because a lot of it is breaking bad habits if you're an existing welder. But it's a very short transition.
It was a very, very good short learning curve for us.
So one of the reasons why we were talking about how much heat you're putting into a part. So when you're using a laser, the power density of that laser is about 10,000 to 20,000 watts of power in a square millimeter. And if you were to take arc welding or MIG welding, TIG or MIG, you're at 50 watts of power in the same area, and that's in that area. So what's the difference? What the difference is when you're doing MIG and TIG, you're adding a lot of heat into the part that's not doing work. Where the laser itself, you can focus it to the bottom of the material, and it's not the power isn't spreading out. It's focused in a spot. So part of the issue with being a great welder, if you're using a TIG or MIG, is you're trying to figure out a way that I'm taking a conductive piece of metal, so any electrons I put in this thing, it's going to want to spread everywhere. Yet how do I get all that power down to the bottom of this joint that I want to melt? And that's the skill. When you're laser welding, when you pull the trigger, you don't have to look for a weld pull. It's there.
How big is the actual beam itself coming out of the end of that torch?
Yeah, so the spot size, it depends on what model machine, but our spot size is anywhere from 2.5 thousandths to 6 thousandths.
2.5 thousandths to 6 thousandths. Okay.
It's
That helps me understand as I was working with it and doing an open butt joint. And a butt joint, I should be the more technically correct term in this case. You want the pieces to butt together perfectly. And if you had any gap in there, I found that the little beam was going through, and then interesting things were happening on my tabletop behind me or in front of me.
Right. So one of the secrets of the process is that we're actually oscillating the beam as we're welding. So it's automatically done inside the gun, and that sort of stirs the metal. And then what the other secret sauce is that you want to have a wire feeder. That just makes it a lot easier. You spot weld with fusion, and you want to weld with wire, because the wire, as it's fed into the gun, it actually propels the gun towards you. So the welds look like they're actually welded with a CNC pace. Well, it was a motorized pace. It's the feed of the wire.
And what we're seeing with the manufacturers, the OEMs of the cars, is they're using this for laser brazing roof panels on. They're using this to laser weld seams on stainless steel panels that they don't want to see a heat mark on the outside. So they can be very precise with this. And if we show that little ditch molding there, this replicates like a roof molding, let's say on a Honda or a Nissan or something like that. And you can see how small that bead is down the center there. It's maybe an 1/8 inch wide. And that pretty much replicates exactly what the OEMs are doing, because they're using this same exact technology, only in a robotic setting in the manufacturing facility.
Yes, and in this case here, we have the one weld on this side is a single wire pass, and on the other side we're actually feeding 2 wires at the same time to give it a larger fillet, probably more like what you're used to now.
A little wider profile.
So that was one of the more challenging things for me to start to wrap my head around. Was with traditional MIG-MAG welding, I'm building a weld profile and I'm dwelling in that area longer with my torch, if you will, versus this process, you're essentially laying down as much electrode wire, the diameter of the electrode wire in a particular point, and moving on. You're not dumping more wire in one spot.
No, we're not building it up.
Right.
Right.
Your travel speed is very close to the speed that you're pushing wire out.
Yeah.
So if you're used to MIG welding and you're kind of going slow and watching the puddle move and all this, you're going way too slow when you pick up a laser welder. You're going to run probably 5 to 10 times faster with this, and that's one of the benefits of it.
Correct, and that's probably why the first weld you made didn't look.
Struggled.
So
I'm still struggling.
we have a booth over at 30217 right down the line here, and we are having customers come in and doing some wire welding with the light weld and some tack welding. So feel free to come visit us, please. But seriously, we have customers. They weld one coupon. We tack weld 2 pieces overlapping. We weld one coupon. Then we flip the part over, and then the guy makes another weld, and the second weld always looks great. The first weld, not so much.
But that's how short the learning curve is.
It's not a steep learning curve. So this is the other thing too, is when you take like a MIG or a TIG weld and you dissect that weld, you cut it in half, you look at the profile. What you see normally is you see a tornado.
A conical shape.
Yes. And in the case of and this is an example of, I think this is 1/8 inch material, and it's an example where the weld, even though it's not parallel, it's a lot more parallel than you would think. And and the reason why that works so good is because now when the metal recasts, it gets hard again. The top and the bottom are about the same size, so you don't get the warpage you do with other processes. And you certainly don't have to fixture the part to allow the part to get cool.
Right, yeah, because it's almost cool as soon as you're done. That was one thing we noticed is we'd weld coupons together, and as soon as we were done, we were able to touch that coupon without getting our hand burned.
Yes, oh, for sure.
Or if that was a MIG weld, we'd have gotten blistered.
It takes a long time.
Yeah.
So we can probably start this video here. This is a, I think the prompt is on the bottom. There it is. But everybody asks, are the welds strong? So in this video, what we're doing is we're welding an aluminum coupon, and that's just a fusion weld. There's no wire in this case.
So the laser itself, it's a spectrum of light that we can't see.
That's right. It's infrared. So it's 1090 nanometer. It's just outside of the visual.
Okay, so any light that we're seeing there is
UV light.
Okay.
So it's about 1/10 of the UV light as MIG or TIG. You're not going to get a sunburn at laser welding, that's for sure. But the white light you see is UV. It's not doing any work. It's just a byproduct of the weld itself.
And you'll notice they are wearing special protective glasses, which they can show you back at the booth.
Yeah, yeah. And they're comfortable to wear. They're 90% light transmissive, so it's okay for, if you had everybody in the shop just with those type of glasses, it wouldn't be a problem.
I noticed the welding helmet that he had on for whenever he's actually up close and personal with the welding process. That was kind of unique.
We got that from Star Wars.
Okay.
Yeah.
Nice. And I see on a lot of the forums and stuff online, people see laser welding for the first time, and it kind of looks like voodoo. And they're like, well, that can't be strong. It's such a small weld. That's just weaker than normal welding, or this is just trickery, camera work, whatever. And no, it's the real deal. These panels here are fully fused together, even though that weld pool is only a couple of millimeters wide.
On the video here, they're doing the pull test here, and you can see where it breaks is not even in the heat affected zone.
Right, and on a normal mag weld,
it
would almost always break in the heat effect zone. Where here
right.
we're actually ripping the base metal apart before we're even touching the weld or the heat effect zone, if there is one.
Right. Do you want to show the camera up here? We can show this part. But this is aluminum, and you can see there's no distortion in that part. I'm sure there is, but nothing I can see.
Nothing visible, yeah, for sure.
Right.
And that piece we've got there kind of replicates a rocker section out of like a Land Rover, Jaguar, anything that's aluminum intensive, something like that. And in that hat channel, we call it, you've got a vertical, you've got a horizontal, you've got a overhead, and we were able to run that with one pass with a laser weld all the way around very quickly. I mean, that weld took, what do you think, Jeff, 4 or 5 seconds? It's fast.
I will say this: none of these welds were done by me because I'm not that good.
Me either.
So talking about the technique, that is a challenge for muscle memory welders like me that have pulled the trigger on a traditional machine for so long that now, again, breaking all of those habits is tough to do. And it's something that I'm working through, and it's going to take a little bit of time. But our intention at ICAR is to continue to research and evaluate and look at ways that potentially this applies out there for vehicle repairs at some point in the future, because there is, I think, some opportunity. Whenever I saw this fender flare, and there's a video online on YouTube of the gentleman that did it, I forget his name.
Evan with Sarah Laser.
Okay, so you can look that up. But whenever they put that flare on that fender, and he went around that, the speed at which he went around that is impressive. I would highly suggest you take a look at the video, and also, if you're here at the show, go ahead down to IPG's.
Yeah. So what he had done here is he had actually used the laser itself to clean the paint off the part, and then he tacked the flares in place, and this is about it. He told me this is a 2-minute weld. He started on one side and went all across the bottom. He didn't jump around. He just welded it, and you can see there's no distortion at all. And then he came back. Before he came to the show, this part's been sitting in, I guess, in their shop. He had some rust, so he used the same machine to clean that rust off. And again, he's not using chemicals. So when you're welding, let's say you're welding aluminum, or you don't have to worry about oxidation on the part. You may want to clean it and remove the oxidation, and that's fine. But to actually do a weld, that's not going to inhibit welding that part.
Which is very different than with MIG welding.
Well, with MIG welding, the oxidation, there's resistance to that, so it changes the flow of the electrons in the part. So you clean it, and then you need to get back to it, in 10 minutes?
Yeah,
because you need to clean it again. So you could use this process if you were doing a MIG or TIG operation, and you still wanted to do that. You could use the laser just to clean that part.
Yeah, which is a nice way to do it.
So if you want to start this video, this is an example of the actual cleaning with a laser.
So a little different head on the machine there. We got a little wider cone.
And the cone is shorter. We're changing the focus. Mm-hmm. So the machine is calibrated that the tip of the gun is the focal point of the laser. And this is a fusion weld. That's 1/4-inch aluminum. That is not automobile specific.
So basically, they're just butted together, and now he's coming along. And
that's right.
No filler wire.
So this is the type of scenario where if there's any gap or void in there, that beam will get through and potentially affect something behind it.
Yeah, typically the amount of gap, if you're not going to use wire, the amount of gap that's acceptable is about half of the material thickness. So if you have 20 thousandths material, that'll be a pretty good fit up. Hence you use the wire.
Yep.
So this is the, you can start this video also. So this is that same part that we showed with the silicone bronze wire. And the demonstration there is that we were doing a single pass with one wire, and then a single pass with a dual wire. I don't know if we're going to run this or not.
Here we go. I think it's going.
So here on the bottom of the machine, you see those two white tubes or opaque tubes. That's where the wires are being fed into the base of the weld pool. And you can see how quickly he's moving. I'm assuming this is a real-time video because that's about the speed that you're going.
Of course.
And the wire feeders for these look like a traditional small MIG-MAG welder setup, just dedicated as wire feeders.
So I probably can't disclose who or how many, but I will tell you it's more than 10. But we have several automotive manufacturers that have these handheld laser welders, and they go back and they're repairing the CNC welds that were laser welded in the factory. Mm-hmm. And the reason why this is so good is that for that type of operation is that they can repair those welds on the line. They don't have to take the car off the line to do that welding, because you don't need to prepare for your electronics. So since we're welding with photons of light, any type of electrical circuits, that sort of thing, it's not affected by the laser welder.
Yeah, unlike traditional TIG welding or MIG welding,
where you might need to remove a car battery, or you might need to remove some electronics that are adjacent to the weld.
Yeah.
Oh, we can start this. This is a perfect example. So, in this case, this is an electronic device that's being encapsulated by laser welding into a metal area. So these lasers are actually used, in battery manufacturing itself. So it's just resistance welding isn't going to work in those cases.
A reference, I think, for a lot of collision repair folks and folks that work on vehicle body structures are the tailor welded blanks, where they've got different thicknesses or strengths of rail of material. We see it pretty commonly in frame rails, sometime in door shells and things like that in the vehicles, and it's all laser done. Most likely in the sheet form before the part is stamped and formed, I would assume.
Yes. I was actually involved in an Italian company years ago that we actually made a tailor blank machine, and they were probably more popular in Europe than the United States. But
so talk to us a little bit about the safety considerations, because there's an element of this that concerns me, scares me a little bit.
Okay.
I'm going to put it out there. You know?
All right. Well, the PPE is different than what you're used to. So that's the hardest thing to get over, is that it's just different. It's not, nobody's ever been electrocuted by operating a fiber laser. Nobody, you can have a pacemaker and still weld. But since the light is invisible, you need to have eye protection, and that's the main thing. And and they have specialty glasses for that. They're readily available. And then we have customers that these glasses, they'll let in 90% of the ambient light. So they'll have cases where they can't actually do the welding in an enclosed area, maybe like an auto collision place, right? Where they might just have a barrier, and then the people around inside that barrier would just wear safety glasses, and it's perfectly safe.
They're special safety glasses.
Yeah,
special laser safety glasses. Yeah.
Yes, yeah, not sunglasses.
Right.
So then we also when we weld with the welder itself, we usually have the welder wearing a welding helmet in addition to the glasses, and customers always say, well, why do I have to have my glasses on underneath my helmet? It's because just like how many times on your MIG or a TIG that you've gone to tack something and you didn't flip the welding helmet down, you just want to make sure that you're protecting your eyes.
Yeah, and I've even spoke with a manufacturer of a helmet special for laser welding that had an interlock switch on the side that actually shut the laser off anytime you flipped your helmet up.
Yeah. We've looked into that. Unfortunately, the welder, you know how welders are; they don't like the extra weight.
I understand.
We're still dealing with welders, so.
Yep. So at this point, I don't know of any manufacturer that's approved this method for the repair process in a body shop to actually fix a car. We have talked with a lot of manufacturers about it, and they're very interested in learning more about the possibility of that being something they could do in the future. We know they're using it in their factories. We know they're building the car with this technology. So the metallurgy and the process is known to them, which is helpful. Can you talk to that at all?
Well, I'm counting on iCar to be my ambassador into that world.
And we are definitely talking with them and showing them what's out there. And we're going to be doing some more research this year. We did get our own welder. We set up a room just to do this. And we're going to be doing some testing with different manufacturers that have interest in it to show them what is possible. Where are there pitfalls? Are there challenges? Are there things we need to know? But like you said, the safety thing is probably the biggest concern they have. Is they don't want to put a procedure out there that somebody could get hurt doing. But
right.
If you know what you're doing, it's probably no more dangerous than using a normal welder.
We don't
just have different PPE.
It's different PPE is what it is, and it doesn't really matter the aspect whether you're upside down welding or vertical or whatever. To the laser, it's physics. It's the same. And you were talking about the qualifications. So the SERS presentation at 2:30 today, or 3:30 today, is actually going to be, we're going to have an expert on qualifications, Rex Alexander, formerly of SpaceX. And SpaceX is, at SpaceX, they use hundreds of these machines. So the Starship rocket that goes up, that you've seen so much about, there's about a kilometer of total light welds in that vehicle.
The cool one that came right back down and got caught, right?
Yeah, exactly.
That was awesome.
Yeah. Oh yeah, we get excited.
Oh yeah.
It's good stuff.
Yep. So we definitely plan to continue the research and testing and evaluation. We're going to be working with you all on this and on the education part of it, us understanding better and how to better advise and educate the industry, the collision industry on it. Because again, I look at the evolution of welding from oxyacetylene welding to traditional old stick arc welding to MIG-MAG welding, and sometimes the amount of time it takes our industry to transition from one process to another, and most of our professional collision repair shops out there have resistant spot welders. We always have to be cautious and realistic to ask the question, what problem are we solving? And what opportunities are there? I look at this though, and it really excites me to be able to think that potentially I can do that. Wow.
Yeah. And we're seeing some fabrication shops that are already using these. So people that are building the beautiful cars that you see here at SEMA, a lot of them already have this.
Yes.
And they're using it because they can make that 3-foot-long weld in a few minutes without any warpage. So if you're hand fabricating panels and putting them together, this is a lot faster and a lot better when you're done. And to me, it's just amazing to see. I've watched a lot of videos of those guys putting 6 panels together to build a fender, and they're just welding it in complete passes. And when they're done, there's no planishing, there's no finishing. I mean, it's take a D8 with 80 grit over it, and it's done. It's ready for a skim coat.
Yeah, and there's a lot more to welding than just laying down a bead. So, you can't find the right labor now, and you bring somebody in, and yeah, you can maybe teach them how to TIG or MIG a joint or anything, but it's how do you lay it out? How do you fit it up? And there's a lot of skill in that, but there's a lot of people in your shop that have that skill, and we find that in that case, you can take somebody that maybe doesn't have the welding skills and have them do the setup and then go ahead and perform the weld and be successful at it.
Right. You're a lot more successful early on with this process than you were when you were learning how to MIG weld or gas weld or TIG weld, for sure.
Right. It's I would say it's more democratic. More people can be in the shop can be involved in that process.
Well, the neat thing is the one machine can do steel, aluminum, stainless steel, silicon bronze. You're just changing out the wire feed on those different materials, possibly changing out the gas, and you're using the same machine to do all that, and you're just as successful on aluminum as you are on steel.
Yes, it's really the process is no different except you have soft wire.
Yeah.
And nobody likes that's always a pain.
So the gun itself, I call it the gun, the torch. It's not a torch.
It's actually a laser head. Yeah.
That's another piece that I have a little concern over, in a sense that the robustness. How much abuse is it going to take from me, the shop collision structural tech that's out there, and I'm a little tough on tools.
No, I get it, and there are optics inside that gun. So we have a holster that sits on that's magnetized. That you can sit on the car or on a work table or something and put it in the cradle. But yeah, don't drop it.
So just reinforcing the fact that I'm going to have to take certain ownership and the reality of that's a pretty expensive unit if I damage it.
It is, but we acknowledge that if there's a weak point of the technology is that that a human being is delivering that beam.
Yeah.
So we've done a lot of things to reinforce that to make it more battle ready, and we've also lowered the price on replacing them. So.
And everything in that is serviceable.
Absolutely.
We bought the service kit when we bought the machine just to make sure we had extras in case Jeff gets a little wild.
Yeah, we're very vertically integrated as a company. We go from the chip level, making the actual chip that's making the light, to the final assembly just outside of Boston. It's all done in Massachusetts.
Excellent. Well, and hopefully next year we're going to get back together and we're going to have a lot more research and a lot more information. And we'll have a different story to tell about the same equipment.
I'm looking forward to it. I appreciate you having me again.
Thank you, Dean. It's been a pleasure as always. Jeff, thank you for joining us up here. Love everything that you're doing for iCar and all the mad scientist projects you get involved with. And thank you all for being here today, and have a great SEMA.
Thank you.
Thank you.